Welcome to our channel, your gateway to the wonders of science and discovery. In today's video, we're embarking on an intriguing journey into the origins of water on the planet Earth. Join us unraveling the mysteries of the universe's history through isotopic analysis. Get ready to dive deep into the cosmos like never before. An international team of scientists may have unraveled a critical mystery about Earth's water origins, pointing to an unexpected source: the Sun. New analysis of an ancient asteroid suggests that extraterrestrial dust grains transported water to Earth during its formation. Researchers from the UK, Australia, and America detail their findings in a recent paper published in Nature Astronomy. The water found in these grains was created through space weathering, a process in which charged particles from the Sun, known as solar wind, interacted with the grains, altering their chemical composition to form water molecules. This discovery could provide an answer to the long-standing question of how Earth, uniquely rich in water among rocky planets in our solar system, acquired its oceans covering 70% of its surface. It could also aid future space missions in locating water sources on airless worlds. For decades, planetary scientists have pondered the origins of Earth's oceans. One theory suggests that C-type asteroids, a type of water-carrying space rock, could have delivered water to Earth during its final stages of formation 4.6 billion years ago. Scientists have previously examined the isotopic fingerprint of C-type asteroids by analyzing water-rich carbonaceous chondrite meteorites that have landed on Earth. If the ratio of hydrogen to deuterium in these meteorites' water matched that of Earth's water, it would suggest that C-type asteroids were the source of Earth's water. However, the results of these analyses were not conclusive. While some water-rich meteorites did have deuterium-hydrogen ratios matching Earth's water, many did not. On average, these meteorites' isotopic fingerprints did not align with the water found on Earth. Earth's water has a slightly lighter isotopic fingerprint than these meteorites. This discrepancy suggests that while some of Earth's water likely came from C-type asteroids, there must have been at least one other source of isotopically light water from elsewhere in the solar system. To investigate further, a team led by the University of Glasgow used atom probe tomography to analyze samples from a different type of space rock called an S-type asteroid. These asteroids orbit closer to the Sun than C-types. The team studied samples from the asteroid Itokawa, collected by the Japanese space probe Hayabusa, and returned to Earth in 2010. Using atom probe tomography, the team meticulously analyzed the atomic structure of grains from Itokawa, detecting individual water molecules. Their findings indicate that a significant amount of water was formed just below the surface of dust-sized grains through space weathering. During the early solar system, space was filled with dust, providing ample opportunity for water to be produced beneath the surface of these dust particles. The researchers proposed that this water-rich dust would have descended onto early Earth alongside C-type asteroids, contributing to the formation of Earth's oceans. Dr. Luke Daly explained, "Solar winds consist mostly of hydrogen and helium ions flowing constantly from the Sun into space. When these ions collide with an airless surface like an asteroid or a dust particle, they penetrate a few tens of nanometers below the surface, altering the chemical composition of the rock. Over time, this space weathering effect can release enough oxygen atoms from materials in the rock to form H2O, or water, trapped within minerals on the asteroid." To ensure the accuracy of their findings, the researchers conducted additional experiments with other sources to validate their results. Dr. Daly explained, "The atom probe tomography system at Curtin University is world-class, but it had never really been used for the sort of analysis of hydrogen we were undertaking here. We wanted to be sure that the results that we were seeing were accurate." Professor John Bradley of the University of Hawaii at Manoa, Honolulu, emphasized the importance of the study's findings, stating, "Since dust that was abundant throughout the solar nebula prior to the onset of planetesimal accretion was inevitably irradiated, water produced by this mechanism is directly relevant to the origin of water in planetary systems, and possibly the isotopic composition of Earth's oceans." Their research also suggests a potential method for future space explorers to produce water on arid planets. Co-author Professor Hope Ishii of the University of Hawaii at Manoa explained, "We think it's reasonable to assume that the same space weathering process which created the water on Itokawa will have occurred to one degree or another on many airless worlds like the Moon or the asteroid Vesta. That could mean that space explorers may well be able to process fresh supplies of water straight from the dust on the planet's surface." Dr. Daly concluded, "NASA's Artemis project is setting out to establish a permanent base on the Moon. If the lunar surface has a similar water reservoir sourced by the solar wind this research uncovered on Itokawa, it would represent an enormous and valuable resource to aid in achieving that goal. Thank you for watching. Don't forget to like, share and subscribe for more.